Greetings, my name is Jeremy Beckman and I teach math at Natchez Valley High School, and Natchez is right outside of Yakima. Today we're going to talk about solving other types of equations. In the last couple sections we've been talking about solving linear equations, solving quadratic equations, and today we really cover the basis of every other type of function we're going to deal with. Unfortunately, section 2.2 is really big. It's one of the meat sections of Pre-Calc 1. So there's a lot to cover. Tonight's homework's very inclusive of a lot of different topics, so there's a lot of different problems you're going to be dealing with tonight. So let's get started on what we're talking about. Again, today is section 2.2. And the topic for this is solving other types of equations. And just from the topic, you can probably tell this is a big section. It's got a lot in it. When it says other types of equations, we're talking about basically every other thing we're going to have to solve while we're in pre-calc. What do we want you to learn today in this section? The goals of our learning, the first thing, given an equation, estimate where the solutions are by either graphing or looking at the table. Now, with that, what we're looking to do is we're just first off looking to see how many solutions is it possible that we're going to have, and second off, get an idea of where those solutions are so we can check our answer once we get it for reasonableness. So first thing we want you to do today, given an equation, estimate the solutions by looking at the graph of the table. Second thing we want you to be able to do, again, given an equation, we want to find the exact solutions analytically. And again, what's analytically mean? It means using algebra, using any type of manipulation that we do to the equation to be able to find where the exact solution is. We are going to learn several different ways you possibly have seen in Algebra 2 or Core 3 before you came into this class. We're going to use factoring, we're going to use some substitution, we're even possibly going to complete the square. And the third thing we need to be able to do today, be able to determine if a solution is extraneous. And again, something you might have some experience with back in Algebra 2, something you might have seen before when we were dealing with quadratic functions or rational functions. Today, again, we're going to have to be able to see, are all of the solutions that we got, do they go back and solve the original equation that we have? And again, this is a very long section. To the instructor, I am going to give you several opportunities to pause and talk about questions as we're going through. So if you have the remote close by or you're able to pause it on the TV or on the computer, feel free to. And then we are just going to scratch the surface on this today. The rest of this chapter is really solving these equations, dealing with these equations, talking about this concept again. So to get started, let's take a look at a couple examples and dig right into it. Our first example that we're going to talk about today, absolute value functions, going back to what was in the first chapter here in Pre-Calc. So we have the absolute value of negative 5x plus 9 is equal to 6. And what we want to do is estimate the solution graphically and find the exact solutions analytically. So we're briefly going to talk about what does the solution look like, what would it be, and then we're going to take a look at how to find it. So briefly, let's take out our graphing calculators. Let's talk about what these functions look like, and let's take a peek at what we have here. First off, to put the equation in the calculator, go to your y equals button. I have the fancy new TI-84, so it has the absolute value brackets in it. To remind you where the absolute value function is, though, hit second and then catalog, and absolute value is the absolute easiest to find. It's the first one on the list. And again, yours, instead of having the brackets, the fancy type, it might just say ABS with a parenthesis after it. So in y1, type in negative 5x plus 9. We want to take its absolute value. y2, where do we want to find where that's equal to? We want to find where that's equal to 6. And just so we're all looking at the same thing, I'm going to go to Zoom real quick. I'm going to go Zoom 6, just so we're all looking at Zoom standard. First off, take a look at that v. That's the absolute value function. That should look familiar from the parent function, y equals absolute value of x. And take a look at the line, y equals 6. And we have two possibilities, or two locations where that line intersects our absolute value. Those are the two locations that our equation is going to be equal at. Now, just to meet our first goal of learning today, let's talk about and estimate where these are. Let's take a look and see. We have two. They're both in the first quadrant. Let's just take a look real quick. This first one, if we trace down to the x-axis, we can see it's definitely after 0. It's probably a little bit before 1. Probably if you had to estimate, it'd probably be about halfway. Second, if we take a look at where the v again intersects the line y equals 6, we trace that down. Looks to be at about 3, maybe a little bit more than 3. The first question I want you to discuss in your class: why is the graph not the best way to find the solution? Or if it's so easy just to plug these equations in, look at the graph, why don't we just use that to find our solution? And instructor, I'll give you a second to pause and talk about that. Hopefully during your discussion you talked about, well, if you have a solution in an integer, it's pretty easy to see, okay, it happens at about 3, like that second solution. However, if it's not in an integer value, it becomes very difficult to find exactly where those two lines intersect at. So the reason why we use algebra, the reason why we find these analytic solutions is so we can find the exact value. If your life depends on it, you want to know exactly where it's going to happen at. So let's go back, let's take a look at now part 2, how to find the exact solution analytically. Let's go back to our sheet. So we have the absolute value, 5x plus 9 is equal to 6, and we know that with an absolute value there are two different values that the function takes on. First off, the primary value, negative 5x plus 9, will be equal to 6. And then reviewing what an absolute value does to a function, we know that there's a second solution. What it can do is take whatever's in here, multiply it by negative 1, or change the sign of that solution. So it's also possible that we need to take the opposite sign of what that guts is of that absolute value. So our two solutions, or our two possible equations that could lead us to an answer here. From this point, to solve for x or to find our analytic solution, easy linear equation. We'll just subtract 9 from both sides. So we have negative 5x left on the left. 6 minus 9 gives us negative 3. Last step, solve for x, divide both sides by negative 5. And we get x is equal to 3/5. Second part of the second solution we could have had, this negative, remember to distribute it amongst both characters in that, or both terms that are in there, multiplying it through. Negative times negative 5 gives you just a 5x. Negative 1, or negative times 9, gives you a negative 9. It's equal to 6. And then, like any other linear equation, solve that for x, add 9 to both sides. You get 5x is equal to 15. Final step, to solve for x, divide both sides by 5. X is equal to 3. So our two exact solutions, or our two solutions that we have, x is equal to 3 over 5, or x is equal to 3. And again, what does that do if you plug that into your original equation? Those are the two numbers that make both sides equal. Instructor, briefly take a second, see if there's any questions in your class amongst how to get that. And let's take a look at one more. Just to, again, get us started, get us thinking about what we have to do. Example 2. Let's take a look at 6x plus 2 is equal, or excuse me, absolute value of 6x plus 2 is equal to negative 4. And again, another shot to pause. Instructor, go ahead and give your students a second to think about this one. If you want to go ahead and try it on your own, try it on your own. I'll give you a second to work on that. Now, hopefully, before you went too far on this problem, what's wrong with this one? Why can't you do this one? Can the absolute value of something ever be equal to a negative? Nope. So is there any value of x that you could plug in that would get this -4 as an answer? Nope, so this one has no solution. Or the fancy way, you can put the empty set for the solution set for that problem. So again, to go back to what we were originally talking about today, the goal for today, there's two things we have to do. We have to be able to, number one, use the graph of the table to be able to estimate where the solution is. Number two, for all these functions we're going to talk about today, use analytical methods to be able to find the solution. That's an example of how to do it with an absolute value problem. Second type we're going to talk about today is if we have an nth root equation. For this one, let's take a look at an example. Let's go to example 3 here. We have the equation k minus 4 to the 4th power is equal to 9. And again, what we want to do with this one I wanted to use a table. Let's get an idea of where the solution should be using a table. Second one, let's again use analytic ways to be able to find where our solution is. So let's plug this baby back into your graphing calculator. First off, I have k minus 4 to the 4th power. Unfortunately, there's no k button for me on here, so we're going to have to use x again. So x, and we're going to subtract 4. Then to raise it to the 4th power, you have to use the caret and 4. And again, mine's going to look a little bit different once you put that caret in. This one brings up the fancy type. Yours, again, might just have the caret 4. And then where do we want to see that's equal to? We want to see that's equal to 9. So on y2, we're going to put 9. And let's take a look. This one, remember, we wanted to go to the table, so let's go to the table. So we're looking for some possibilities of where our equation, x minus 4 to the 4th power, is equal to 9, or where the solution would be for 9. And we start out with big values, and then we're heading down to 0. Once we get to 0, we start to head back up. So we'll see between 16 and 1, so somewhere between 2 and 3, we are looking for a solution in there. And from 5 to 6, we are looking for a solution in there, again, because it goes from 1 to 16. It's going to hit 9 somewhere in there. If you look at the graph, kind of cheating over here to the side, you can see that's in fact where it's going to hit at. So let's take a look. That gives us an estimate, kind of check for reasonableness of where our solution should be. Let's take a look at how to solve this guy. So we had, again, k minus 4 to the 4th power is equal to 9. How do we solve that? First thing we have to do is get rid of the 4th power. Now, just a review again from either Algebra 2 or from Core 3, whatever you took before this class, to get rid of the 4th power, you have to take the 4th root of both sides. Now, just a side note to that, whenever you take an even root, you always have to be worried about a plus or minus that's going to follow. So you're going to have two possible solutions, or two numbers that could give you that solution out. What's left on the left-hand side, we got k minus 4. What's left on the right-hand side, we have the 4th root of 9. Next step, one that's easy, add 4 to both sides. Traditionally, mathematicians will write the whole integer before. I forgot to write the plus or minus there. They'll write the 4 in front of the plus or minus just so that the plus or minus is after the character. So k is equal to 4 plus or minus the 4th root of 9. Now, just a question to review again. How many solutions do we have out? We have 2 solutions. Going back to our graph, going back to our table, we estimated that there were going to be 2 solutions out. Go back up to the directions, we need to round to the nearest hundredth, so we got to put that back in our calculator. So we have 2 solutions out again, and let's go back to the calculator and put those in.